Okay, let's pick up where we left off with level of measurement video number one. We were abruptly um, stopped by the program. So uh, we made it through our levels of measurement and all our variables, the last one being victimization likelihood and it being ordinal. And now we move to questions 6 and 7. Now I got several questions on 6 and 7, which is understandable and fine. So let's walk through it a couple different ways to talk about it. Chapter 5 discusses that in our 4 levels of measurement, we can actually transform particular variables from one level of measurement to another. Now, realistically, or a practical matter is that we generally only take interval level and ratio level variables and transform them into ordinal level variables, or what I refer to as collapsing particular variables. So we see here with our interval level variable or intelligence quotient, IQ, we're transforming it here from interval to ordinal. And what we're doing is we're just grouping uh, particular observations into one variable or one measure, if you will. So we are going to score our interval level variable or collapse it into 4 categories or 4 attributes. So you know that we actually starting out, we have 11. We have 11 observations or inmates, and they each have an IQ score attached to them. And subsequently, what we have is we have collapsed it into 4 levels. Now, you don't have to make it 4. You can make it actually 2, a dichotomous variable, 3. Here I made it 4 just for illustration purposes. The reality is with in statistical analysis with just 11 observations, you wouldn't do statistical analysis with 11 observations, nor would you collapse a variable. So why you collapse variables from interval or ratio into ordinal is really a statistical purpose. So it's beyond the scope of our course on why exactly we would do this. It's just a recognition that it's done. When we go over the question, so we're going to change the level of measurement, the variable IQ. What measurement are we creating? We're going from interval to ordinal. We're kind of illustrating the transformation here. And our distribution is how many observations fall in each new category. So 2 have an IQ of 69 or below. 4 have an IQ in between 70 and 99. 3 observations have an IQ in between 100 and 119. And 2 have an IQ in between 120 and above. So I want to open up a statistical program with our actual data. So what we want to do, and you can see this is a statistical program, and I put just assignments data here. So it's identical. In fact, let me go ahead and drop a variable so you can see how it's created. So we're going to look at age. So we have age variable over here. So we want to tab age, which basically just gives us our frequency. So you don't have to worry about the statistical program or any of the syntax that's being coded. You can just take a look at exactly what's happening within the data. So this is what we're seeing within the data. We know we have 2 that are 19 and then 2 that are 23 and the rest ones. If you go back to the assignment and we go up to our data set, so to speak, we can see that's true. There is our one 19-year-old, and here's our second 19-year-old. Here's our one 23-year-old and our second 23-year-old. So it just gives us the frequency. And now we're in an age variable, so we are in a ratio level variable, but we want to collapse it. So I know there was the example on the edited version of the assignment that we collapsed it into 4, but let's collapse it into 3. So I'll just show you, here's the simple syntax, which again, you don't need to know, but I'm going to create 3 attributes to this new variable. And I would call them young, medium, and old. So everybody with within the age of 19 and 21 goes into the first group. Everybody with the age of 22 to 29 goes into the second group, and everybody with an age 30 or above goes into the third group. So we create a new variable, and let's get the frequency on that, and see, here you go. What we have is 4 people are between the ages of 19 and 21, so they're in group 1 or attribute 1. And 5 are in the age group between 22 and 29, so they're in group 2, and 2 are over the age of 29, meaning 30 and over. And so that's in attribute 3. Remember, the variable is age. The attributes here are 1 meaning young, 2 meaning middle, 3 meaning old. So let's go back to the assignment and look at our final example. And what we have is prior felonies. So prior felonies, we know, looking at it, is a ratio level variable because it has a true 0. 0 means something. And we go down here and look at the transformation, or the collapsing of this ratio level variable into an ordinal level variable. How I decided to recode this variable or collapse this variable were my first group. I decided people with no prior felony, so people with no criminal history really, and that's 3 individuals, the distribution. And then the second group is 1 to 2 felonies, and there's 2 of them, and then 3 of our inmates have a IQ, or rather prior felonies, 3 or more prior felonies. So if you're thinking about a criminal history or prior felonies, we can say what group has the, I guess, worst or most extensive criminal history? Well, of course, that's group 3. And so you can see how you can rank order those. And through interpretation of the analysis, that becomes extremely beneficial. So going back to a statistical program, which can illustrate exactly how this is done, we want to recode prior felonies. Oh, sorry about that. We want to recode prior felonies with, so 0 equals 1, 1 and 2 equal 2, and 3 and max, 3 and over essentially, equals 3. And then we just we'll generate a new variable, and then we get the frequency on that variable, and we have 3, 5, 3. So we have 11 individuals in our data set. 3 of them have no prior felonies, 5 of them have 1 to 2 prior felonies, and 3 of them have 3 or more prior felonies, which is exactly what you see here. So 6 and 7, you're doing it the same. Keep in mind that you're really only collapsing or transforming variables from either interval or ratio level down to ordinal. You wouldn't, practically speaking, although you could, you really wouldn't make those nominal level variables. So, although you can't, or you wouldn't do that in a practical standpoint in research. So, hopefully this does a good job in explaining the material and exactly what the text is talking about. I know the text has a diagram showing kind of the philosophy behind transforming or collapsing variables. I hope to think, or I'd like to think, that this does a better job of explaining that material. Last thing I want to mention is that although you can go down in your transformations, you can go from ratio to ordinal and nominal, or you can go interval to ratio and nominal. You can never go up. So you cannot make an ordinal level variable, a ratio level variable, or an interval level variable, because without the information, you could never make it truly. You couldn't make it as, I guess, specific or as nuanced. So just remember, you can never go up. You always have to go down in level when you're transforming or collapsing variables. So again, as always, hopefully you found this helpful. If you have further questions about the material, don't hesitate to email me and we can set up a meeting to go over some of this content. I'm happy to do so over WebEx, by phone, or of course, for those of you near Ball State's campus, in my office is fine as well. Okay, thank you.